Hello everyone, myself Ankur Patel, and today in this session of engineering course we are going to discuss Archimedean spiral. So today in this session we will discuss three different problems of Archimedean spiral, but before going on to problems, let us discuss what is Archimedean spiral. So if a point moves on a straight line with uniform velocity and at the same time if the line rotates about one of its end point in clockwise or anti-clockwise direction with uniform angular velocity, then the locus traced out by the point is Archimedean spiral. So here in this figure you can see that the point A moves in the straight line, and at the same time the straight line is rotating in the anti-clockwise direction. Then the curve traced out by the moving point is an Archimedean spiral. So let's start with the first problem. A point P moves towards another point O 75 mm from it and reaches it during one revolution. We can also say that one convolution around it in anti-clockwise direction. Its movement towards O is uniform with its movement around it. Draw the curve traced out by the point P. Also draw the normal and the tangent to the curve. So the given data is the distance between O to P is 75 mm. That means point O moves towards point P moves towards the point O, and the distance is 75 mm. And number of revolution or number of convolution is 1 convolutions. So first of all, draw a circle having radius equal to 75 mm. Divide the circle into 8 equal parts. This will be the center of the circle, or we can also say that for Archimedean spiral, this is the pole of the spiral. So the radius is 75 mm. Right now we have to draw the Archimedean spiral, or the movement or the rotation of the line is in the anti-clockwise direction, and the number of convolution is 1 convolution. So starting from here in the anti-clockwise direction we have to give the numbering on the circle for one revolution. It is equal to 360 degree. So give the numbering in anti-clockwise direction 0, 1, 2, 3, 4, 5, 6, 7 and 8. So for one convolution the number will be up to 8. Now we have to divide this distance from O to 8 or from O to 0 into equal number of divisions. But first of all we have to decide what will be the number of division on this line. So for that, here we have represented an equation. So number of division on this line is equal to the number of division on the circle into convolutions. So the number of division of the circle is 8 and the convolution is 1. So the number of division on this line will be 8. So now divide this line into 8 equal parts. Give the numbering starting from 0, 1, 2, 3, 4, 5, 6, 7, 8 up to the center of the circle. Now after dividing this length we have to draw the spiral. For that the starting point of the spiral will be over here. So this will be our P0 point. Now from the center O, measure O to 1 or as a center O, and radius is equal to O to 1. Give an arc up to the first division. Now take center at O, radius is equal to O to 2. Give an arc up to 2. Center at O, radius is equal to O to 3. Give an arc up to 3. Center at O, radius is equal to O to 4. Give an arc up to 4. Center at O, radius is equal to O to 5. Give an arc up to 5. Center at O, radius is equal to O to 6. Give an arc up to the 6th division of the circle. Center as O, radius is equal to O to 7. Give an arc up to the 7th division of the circle, and the last division will be over here at the center. So mark these points, intersection points of the arc to the divisions. So this will be P0, P1, P2, P3, P4, 5, 6, 7, and this will be our P8. The center will be at P8. Now draw the freehand curve passing through these points will be the Archimedean spiral in the anti-clockwise direction. So draw the freehand curve will be the Archimedean spiral. Now we have to draw a normal and a tangent to the curve. So in Archimedean spiral, if you want to draw normal and tangent, first of all we have to find out a constant. and the equation to find out the constant to spiral is maximum radius minus minimum radius divided by the convolution in radian. So here the maximum radius is 75, minimum radius is 0 mm, and convolution is 2 pi. That means for one convolution the radian will be 2 pi. For 360 degree the radian will be equal to 2 pi. So the answer will be constant will be equal to 12 mm. So first of all we have to draw a circle from the pole or from the center of the circle having radius is equal to 10 mm. So draw a circle. Now mark any point as on the curve. So this will be the point as on the curve. Now connect this point as to the pole. That means connect this S point to the center of the circle and draw a line perpendicular to this line from point O in this direction, and mark the intersection point of this line to the circle of the constant. So here we will get this point, and now connect this point to S will be the normal, and the line perpendicular to the normal and passing from point S will be the tangent. So this is the Archimedean spiral for one convolution. Now let's move on to next problem by changing some data. A point P moves towards another point O, 75 mm from it, and reaches it during 2 revolutions. Now we have changed this data. In place of 1 revolution, we have taken 2 revolutions around it in anti-clockwise direction. Its movement towards O is uniform with its movement around it. Draw the curve traced out by the point P. So here the given data is again OP is equal to 75 mm, distance between O to P. Number of revolution is 2. Right now the number of convolution or number of revolution is 2 revolution or 2 convolution. That means it is for 720 degree, not 360 degree. 360 degree 1 convolution and plus 360 degree is equal to 2 convolution. It is equal to 720 degree. So first of all draw a circle having radius is equal to 75 mm. Now divide the circle into 8 equal parts. So again we have to draw the spiral in the anti-clockwise direction. So we have to give the numbering in the anti-clockwise direction from this point in the anti-clockwise direction for 2 convolutions. So the number of division will be 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 1 convolution. Then after 9, 10, 11, 12, 13, 14, 15, 16, 2 convolution. So after dividing or after giving the numbering on the circle, now we have to divide this length into equal number of divisions. So again, what will be the number of division on this line? For that, we have to use this equation. Number of division n on this line will be equal to the number of divisions on the circle into convolutions. So the number of divisions on the circle is 8 into convolution is 2. So the answer will be 16. So now we have to divide this length into 16 equal number of divisions. So divide this line into 16 equal parts. Give the numbering starting from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After dividing this line into 16 equal parts, now this will be our P0. So starting from P0, now take center at O, radius is equal to O to 1, give an arc on the first division of the circle. Center at O, radius is equal to O to 2, give an arc on the second division of the circle. Center at O, radius is equal to O to 3, give an arc on the third division of the circle. Center O, radius O to 4 on the fourth division of the circle. Center at O, radius is equal to O to 5, give an arc on the fifth division of the circle. Center at O, radius is equal to O to 6, give an arc on the sixth division of the circle. Center at O, radius is equal to O to 7, give an arc on the seventh division of the circle. 8 will be over here, so center at O, radius is equal to O to 8, give an arc, it will be over here. Center at O, radius is equal to O to 9, give an arc on the ninth division of the circle. Center at O, radius is equal to O to 10, give an arc on the 10th division of the circle. Center at O, radius is equal to O to 11, give an arc on the 11th division of the circle. Center at O, radius is equal to O to 12, give an arc on the 12th division of the circle. Center at O, radius is equal to O to 13, give an arc on the 13th Then after center O, radius O to 14, give an arc on the 14th division of the circle. Then after center at 4, radius is center at O, radius is equal to O to 15, give an arc on the 15th division of the circle, and 16th will be over here. So now mark these points, intersection points of the arc to the division of the circle. And give the name of these intersection points. This will be P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, 11, 12, 13, 14, 15 and 16 at the center. Now draw the freehand curve passing through these points, which gives us the Archimedean spiral for two convolutions. Now the method to draw normal and tangent will remain same. Now let's move on to another problem having different data. So draw an Archimedean spiral for 2x3 convolutions when maximum and minimum radius being 60 mm and 20 mm respectively. So here we have two circles, one is the 60 mm and the another circle is of 20 mm radius. So the given data is R1 is 60, R2 is 20 mm and the number of revolution is 2x3 or number of convolution is 2x3. It is equal to 240 degree. So first of all we have to draw a circle having radius equal to 60 mm. Then after draw another circle having radius equal to 20 mm. Make sure that the both circles should be concentric. That means the center of both circles should be at same point. After drawing the circles, now divide the circles into 12 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. After dividing the circles, in this problem also we will draw the spiral in the anti-clockwise direction. So we have to give the numbering in the anti-clockwise direction, but up to 240 degree, not 360 degree or not 720 degree. We have to give the numbering up to 240 degree. So in the anti-clockwise direction, 0, 1, 2, 3, 4, 5, 6, 7, 8. So here we will get 240 degree because 0 to half it is 180 degree, 210 degree and 240 degree. So we have to give the numbering up to this point only, up to 8 divisions only. Now after dividing the circle, after giving the numbering on the circle, we have to divide this length, the length between two circles, into equal number of divisions. Now what will be the number of divisions? For that, let us see this equation. So number of division on this line will be number of divisions on the circle into convolutions. So right now the number of divisions on the circle is 12, into convolution is 2x3. So the answer will be 8. So now we have to divide this length from this point to this point into 8 equal divisions. So divide this line into 8 equal divisions. Now let us change something. We will give the numbering on these divisions starting from 0 over here. 0, 1, 2, 3, 4, 5, 6, 7 and this is 8. You can also give the numbering starting from 0 over here up to 8 like this, but in this case we have given the numbering in this direction. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So after giving the numbering, so now right now the P0 will be over here. Now what we have to do, taking center at 0 and radius equal to 0 to 1, give an arc on the first division. 0 to 2, that means center as O and radius equal to O to 2, give an arc on the second division. Center at O, radius is equal to O to 3, give an arc on the third division of the circle. Center at O, radius is equal to O to 4, give an arc on the fourth division of the circle. Center at O, radius is equal to O to 5, give an arc on the fifth division of the circle. Center at O, radius is equal to O to 6, give an arc on the sixth division of the circle. Center at O, radius is equal to O to 7, give an arc up to the seventh division of the circle. And if we will measure 0 to 8, we will get the 8 division over or 8 point over here. Now mark this point P0, mark the intersection points of the arc to the divisions of the circle and give the numbering. This is P0, so this will be P1, P2, P3, P4, P5, P6, P7, P8, Now draw the freehand curve passing through these points will give us the Archimedean spiral for 2/3 convolutions. So this is it for today. Thank you for watching. We will come with some more problems of engineering curves in our next lecture. Till then, take care.